All right, let's get right into it. We're about to explore what might be the single most ambitious idea anyone has ever had, reaching out and capturing all the power from our own star. And believe me, this isn't just something out of a sci-fi movie. It's a real thought experiment that pushes the absolute limits of what we think is possible. So let's kick things off with the one question that started it all. I mean, really think about it. What if we could actually build a power plant that completely surrounds the sun, catching every last drop of energy it pours out into space? What would that even look like? The number you're seeing right now? Well, that's the answer. That's how much energy the sun radiates every single second. It's 380 followed by 24 zeros. It's a number so huge, so astronomical, that it's practically impossible for our brains to even process without a little context. And here's that context. You see that tiny little sliver on the left? You might have to squint to even see it. That represents the total energy consumption of our entire global civilization. And the massive bar on the right? That's the sun. The difference isn't just big, it's staggering. We're not even a drop in the bucket. And if that chart didn't blow your mind, try this on for size. If we could capture the sun's total energy output for just 1 second, just one, we would have enough power to run everything on Earth at its current rate for the next 670,000 years. That is the kind of prize we are talking about here. It's unbelievable. So, with a goal that massive, where do you even start? Well, you start with a plan, a theoretical blueprint for becoming what's known as a Type 2 civilization. And that idea comes from something called the Kardashev scale. It was proposed way back in the 60s, and it's a really cool way to think about things. It's basically a cosmic yardstick that measures how advanced a civilization is, not by its technology or its culture, but purely by how much energy it's able to control. So, a Type 1 civilization has mastered all the energy on its home planet. A Type 3, well, they've harnessed the power of their entire galaxy. And right in the middle is Type 2, a civilization that controls the energy of its star. That's the goal. And us, as you can see, we're currently sitting at about a 0.73. We haven't even become a true Type 1 yet. We've got a long way to go. The person who really gave this idea legs was the physicist Freeman Dyson. And this quote is absolutely key to understanding it. Notice his words, a loose collection or swarm. He never imagined some giant solid shell encasing the sun, which is a mistake you see in pop culture all the time. And this difference is so important. A rigid Dyson sphere would probably be impossible to build and would be gravitationally unstable. It would just tear itself apart. What Dyson actually proposed was a Dyson swarm. Basically, trillions of individual solar collectors, all flying in their own independent orbits, forming a massive, dense cloud around the sun. Okay, so we have the vision, but now we get to the hard part, the challenge. Because even this more realistic swarm idea would require an engineering project so vast, it's almost impossible for us to wrap our heads around today. First question, where do you get the stuff to build it? There's just not enough material on Earth, not even close. To build a full swarm, we'd probably have to, dismantle an entire planet. Mercury is often talked about as a good candidate. Some calculations even suggest we might need all the mass from a gas giant like Jupiter. Yeah, taking apart a planet. So the basic roadmap would look something like this. First, you'd need an army of self-replicating robots. You'd send them out to mine asteroids and planets, use those raw materials to build trillions, literally trillions of little orbiters, and then somehow manage this impossibly complex cosmic dance to make sure they don't all just smash into each other. No big deal, right? And don't expect this to get done in our lifetimes, or our grandkids' lifetimes. We are talking about a project that would span generations, maybe even thousands of years. It would demand a kind of long-term vision and unity that, frankly, humanity has never really shown before. But what if we could? What if we actually pulled it off? Well, if we could overcome all those insane hurdles, the reward would be a utopia. It would completely change the definition of what it means to be human. Think about it. The most obvious benefit? We'd have basically infinite clean energy. Scarcity would become a thing of the past. The conflicts we have today over oil, over resources, over territory, they could all just fade away. Our environmental problems on Earth? Solved. And we wouldn't be stuck on this one little rock anymore. Civilization itself could move out into the swarm. We could have trillions of people living in these incredible custom-built habitats orbiting the sun. We'd become a true constellation of worlds. And that kind of energy would unleash a golden age of discovery. You could power computers the size of planets, create virtual realities that are indistinguishable from the real thing, and even build massive laser arrays powerful enough to send ships to other stars. The possibilities are endless. But here's the turn, because with godlike power comes godlike risks, and achieving this dream could just as easily turn into our worst nightmare. And these risks are enormous. I mean, do we even have the right to take a planet apart? And what happens if our entire civilization becomes totally dependent on this one gigantic, fragile machine? And then there's the big one, the really scary one. What if we're not alone out there? And this is the core of what's called the dark forest hypothesis. By building a Dyson swarm, you are essentially hanging a giant neon sign on your solar system that says, "We're here." It would be an unmistakable beacon of advanced technology, visible from light years away. It's like lighting a huge bonfire in the middle of a dark, silent forest when you have no idea what might be watching from the trees. So this huge, futuristic idea actually forces us to think about the choices we're making today. It really frames the kind of future we want to build. And believe it or not, this isn't all just theory. We're already taking the first baby steps on this path. The ideas behind space-based solar power, the research into asteroid mining, the quest for fusion energy, these are the seeds. These are the foundational technologies that could, one day, lead to something like this. And I think this quote really gets to the heart of it. Just thinking about this, aiming for something this grand is a choice. It's a choice to try and solve our problems with growth, expansion, and abundance, instead of just fighting over the dwindling resources we have here on this one little planet. So, that leaves us with the ultimate question, doesn't it? Is building something like this our destiny? The next logical step for a smart species? Or is it a temptation for a level of power that we simply aren't wise enough or unified enough to handle? That really is the question for our future.